I'm Tiffany.
Wait. Start over.
I'm Tally.
I'm Tiffany.
I'm Avery.
I'm Alice.
I'm Rachel.
And we are ronagroup1.
As our group name suggests, we are using machine learning to take on one of the many problems caused by COVID-19. So what is the problem? Throughout the recent COVID-19 pandemic, many hospitals have run into a major problem. They are running out of supplies such as hospital beds and ventilators to treat their patients. There are a few ways to tackle this problem. First is to reduce the spread of COVID-19. Second is to increase the number of supplies available. And third is to give the doctors a better idea of the amount of supplies and space that they'll need so they can prepare in advance. Today, we will be focusing on the last method.
Our goal with this model is 1. To allow doctors to prepare treatments and equipment in advance, such as ventilators if a patient needs to be intubated and ICU beds for patients. And 2. To classify a patient's risk factor based on their pre-existing health conditions. Our risk factors are intubation, being put in the ICU, or if a patient is unlikely to survive.
For our data set, we used anonymized patient data collected by the Mexican government, which has many true or false questions about various pre-existing medical conditions, such as diabetes, asthma, and obesity. Over 500,000 patients were surveyed for this data set. Since the data only deals with Mexican patients, it is important to note that the data may not necessarily reflect the population of other countries. The data also has information on the outcome of the patient, such as whether they tested positive, whether they went to the ICU, and whether they died. For this model, we only used the patients with positive COVID test results because we wanted to determine what would happen after someone gets the virus instead of whether someone has it. Because a very small percentage of patients experienced positive outcomes, less than 2% of patients went to the ICU. We decided to use a technique called oversampling, which is when you add synthetic data to the data set to balance out a majority.
We tried to predict the likelihood of 3 different outcomes: intubation, ICU admission, and death. Because these outcomes aren't mutually exclusive, we decided to make 3 separate models, one for each outcome. These 3 models would be very similar in structure, but fine-tuned to each risk factor. We also used a machine learning model called a decision tree. Essentially, this model is composed of a series of yes or no questions that are designed to separate the data into classes.
As you can see here, the root node is the initial question. For this decision tree, the root node is a salary threshold. Either the job offers enough money or it doesn't. From the root node, the data is passed through a series of decision nodes, each asking a yes or no question, until it reaches a leaf node. The leaf node has the result on it. The decision tree shown here is a very simple version of the ones that machine learning algorithms are able to generate. Our decision tree models were created using a Python package called sklearn. sklearn is designed to automate the training process, meaning that given a set of training data, the computer generates the nodes instead of us manually having to input each one.
Thank you. Stay tuned for our results coming in our live presentation.
As our group name suggests, cut the cameras.
From the root, the lighting went whack in my video.
Wait, I forgot to read a paragraph.
Yeah.
Can we start over?
This is getting worse and worse.